Welcome to this video session. My name is Samuel Chukwu Emeka. In this video session, we shall discuss factoring using the method of the difference of two squares. Okay? We shall factor algebraic expressions using the method of the difference of two squares. Now, before we go into the difference of two squares, we would like to, we ask ourselves, what is the need for this? We use this to factor a lot of algebraic expressions and equations. Even when there are some applications in real world word problems that will entail squares, and once it entails the difference of squares, then there is a possibility that you would have to apply this method. Before we go to difference of two squares, we want to kind of recall our order of operations. Assuming we have a 5 squared minus 2 squared. Okay, this is difference. Of course, the minus, remember, difference is the answer you get after subtraction. And then this is 5 squared minus 2 squared. So this is difference of two squares. Okay, difference of two squares. You have the first square is the 5, and the second square is the 2, because this is 5 squared and this is 2 squared, and the difference is the minus. Okay, so if you are solving this, if you are asked to solve this, probably the first thing that comes to your mind is PEMDAS, right? You still remember PEMDAS? Please excuse my dear Sally. That is the order of operations: parentheses, exponents, multiplication, division, addition, and subtraction. So it kind of comes to your mind that this is exponents, right? And this is correct. So if we are using PEMDAS, if we use PEMDAS here, if we want to use PEMDAS here, the exponent 5 squared is 25, minus 2 squared is 4. And what do you have? 21. If we are using PEMDAS. But now, this is arithmetic, numbers. You easily did it with numbers, right? Because you could manipulate it. But how would you now do something like x squared minus y squared when you now have algebra? This is arithmetic, numbers. This is algebra, variables or letters. How are you going to do this now? How would you do it? Because you don't know what x is and you don't know what y is. Okay, you don't know the value of x and you don't know the value of y. So now, scientists, mathematicians now came up. Is there any other way we can solve this so that we can apply it to algebra? Right? Is there any other way we can solve this kind of question so that we can apply that method to algebra? That was when the difference of two squares method now came up. Okay? So if we now use the difference of two squares here, difference of two squares, then what we'll have, if we have 5 squared minus 2 squared, this will be 5 plus 2 times 5 minus 2. Okay? 5 plus 2 times 5 minus 2. And 5 plus 2 is 7 times 5 minus 2 is 3. 7 times 3 still gives you 21. So you see that this method also works for arithmetic. But an important step forward about this method is that you can apply this now to algebra. You can apply it to algebra by saying that x squared minus y squared will be x plus y times x minus y. So you have directly factored it immediately. You have factored it out. That means you've broken it into two factors. Okay? Into two products. You have factored it into two products. right? So this is a very important method to use in both arithmetic and in algebra. And in that case, even we apply this method when we do rationalization. When we rationalize radicals, we apply this method, we use that method. When we rationalize complex numbers, when we do division of complex numbers, and we have to rationalize the denominator, we apply the difference of two squares principle. Okay, so now there is a way to kind of learn it, and we will sing it as a song in this video. Okay, so we see that this is sum, right? And this is the difference. You see that this is sum and this is difference, and then this is product also. You know that this is product because this means x plus y times x minus y. So this is your sum here. This is your sum. This is your difference. Sum is the answer you get after addition. Difference is the answer you get after subtraction. And this becomes product is the answer you get after multiplication. So can we sing it like a song? That the difference of two squares is the product of their sum and their difference. The difference of two squares is the product of their sum and their difference. You see that? The difference of two squares is the product of their sum and their difference. Again, the difference of two squares is the product of their sum and their difference. I mean, by the time you sing it a lot of times, you will know it. Okay? I don't know, I'm kind of hype at the same way. Anyway, so this is product of their sum and their difference. The difference of two squares, x squared and y squared, the difference of two squares, x squared and y squared, is the product of their sum and their difference. Okay? Alright, I hope you have smiled a bit, right? Okay. So let's do some questions right now on the application of this. And then, now, before I go, I have done the notes, and the notes are on my website, so you can view the videos with the notes. The notes are on my website. All right, let's get started now. Let's do all the problems we shall do tonight. What we want to do is that we want to express it in form of x squared minus y squared. Once we can get it to look like this, then we can apply the difference of two squares. X plus y times x minus y. So this is the basic. All our problems, we want it to look this way so that we can easily apply it right away. Okay? And this is part one of this, so watch out for part two. Now, number one, p squared minus 1. Okay? Now, how would you make this to look like this? You see, p already has squared, so we are good. But 1 doesn't have squared, right? But anyway, 1 squared is equal to 1. So this means p squared minus 1 squared. Okay? So if you compare this, we see, if you compare to x squared minus y squared, we see, if we compare this x squared minus y squared, we see that if we remove the squared, we see that the p is x now. Okay, and the 1 is what? Y. Do you see that? Our x is p, here our x is now p, and our y is what? 1. Because that's the main thing. That is the main thing. To get your x and your y. So that when you can get your x and y, all you need to do is to substitute it in the difference of two squares. and you are ready to go. Okay, so we see now that p squared minus 1 will give us, of course, our x is p plus 1, because our y is 1, times p minus 1. And that is it. Our x, each one we want to find our x, and we want to find our y. Our x is the p, and our y is the 1. Okay? So we see that p squared minus 1 will be p plus 1 times p minus 1. And that is it. Okay? So we see that our x is p, our y is 1. So p squared minus 1 is p plus 1 times p minus 1. That is it. Okay, question 2. Question 2, k squared minus 16. Right? So k squared is in form of x squared. So here our x is k. We are good, right? But 16, how are we going to make 16 to be squared? Okay? And the easiest thing is you ask yourself, what number will you square to give you 16? In other words, what is the square root of 16? That is what it means. What number are you going to square to give you 16? Okay? What number? Maybe y squared to be 16. Then y will be what? Square root of 16. And y will be 4. So you see, you will square 4 to give you 16. Okay? So that's the way you do it. What number will you square to give you 16? And that is 4. So this will be k squared minus 4 squared. Because your y squared is 16, and you take the square root of both sides, y will now be 4. So in this case, our x is what? Our x is k, and our y is what? 4. Okay? So we see that this will now give us what? X plus y, which is k plus 4 times k minus 4. And that is the answer. K plus 4 times k minus 4. That is it. You see how simple it is. Okay? Let's do the third question. We have 16 questions to do. 16 questions to do. 25x squared minus 36. Here, I want you to be careful here, you know. Here, 25, can we put this to be squared? Is it possible that we put this to be squared? In other words, what number would you square to give you 25? Which means, what is the square root of 25? That is 5 squared. So this is 5 squared, x squared, minus 36 is 6 squared. Okay? And you don't stop here, because we are good for the 6. Our y is 6 here. Our y is 6, which means you are good. But here we have two things here. So how are we going to make it to be one thing? This means 5x all squared minus 6 squared. You see that now? Because law of exponents. Law of exponents. So this means that our x here is 5x and our y is 6. That is what it means. Our x is 5x and our y is 6 when you compare it. So this means that this will give us what? 5x plus 6 times 5x minus 6. And that is it. And you know the thing now, when you want to check this, you know you can always check this. If you multiply this, you can use FOIL. If you use FOIL and multiply this, it gives you back this. Okay? I'm not going to check in all of them, but let's check on this one. If we want to check on this one, this will be 5x times 5x, 5x times negative 6, 6 times 5x, and then 6 times negative 6. So this will be 25x squared. This will be negative 30x. This will be 30x. And this will be negative 36. So 25x squared minus 30x plus 30x, this is gone. You now have 25x squared minus 36. What you had in original. This is the way you check it. Okay? Alright, we still have more questions to do, so let's get it going. Number 4, question 4, 16x squared minus 81y squared. Okay, here, the 16, we know is 4 squared. Okay, so this is going to give us what? 4 squared x squared minus 81, we know is 9 squared. This is 9 squared y squared. Okay? So you combine this because you know your x is just a single entity. This is double entity. You want to make it single entity. So this will be 4x all squared minus 9y all squared. So in this case, your x is 4x. In this case, your x is 4x and your y is 9y. Okay? So this will now give you what? This will give you 4x plus 9y times 4x minus 9y. You see that? You can write this by the side so that it doesn't conflict with what you're doing. Okay? You can kind of write it as rough work. So this is your main answer here. Alright? And if you expand this, if you multiply this, you get back this. Question 5. I want you to pause the video, solve it before, like always I say this in almost all my videos. When I give a question, like I give it now, j squared minus 64y squared, you kind of want to pause it. You want to pause it first, do it on your own, and then after doing it, you now continue to check whether we got the same thing. Now, if we did not get the same thing, check your work. Okay? I mean, if we don't get the same thing, check your work. If I made a mistake, then you make the comments and let me know, or you just send me an email and I will correct myself. Okay, so in this case, our j, we are good. Our x is j, but we don't know what is our y. Let's make it compact. Let's make it one entity. So this is 64 is 8 squared, y squared. So this is j squared minus 8y all squared. So our x is j and our y is 8y. Okay, our x is j and our y is 8y. So this will be j plus 8y times j minus 8y. And that's the answer. Question 6. We are coming up. We are coming up. So this is the basic thing. Question 6 says a squared b squared minus c squared d squared. Okay? So make this a single entity so you can find your x. This is ab all squared minus cd all squared. Alright? In this case, what is your x? Your x is ab, okay? And your y is what? cd. Your x is AB and your y is CD. So this is what? AB plus CD times AB minus CD. Comprendez? Si. Comprenez-vous? Oui, comprenons. Question 7. 36p squared q squared minus 16. Okay? So this will be what? 6 squared p squared q squared minus 4 squared. Okay? Make this compact. This will be 6pq all squared minus 4 squared. So in this case, what is your x? Your x is what? 6pq, and your y is what? 4. Okay? So this is going to be what? 6pq plus 4 times 6pq minus 4. That is your answer here. Okay, question A. We are halfway through the problem. A, k raised to power 6 minus 49m squared. You know, why I have 16 problems is that I want to touch everything. I want to touch all the varieties, you know, kind of questions you might experience. All right. Here, how do we make this to be x squared? Now, these laws of exponents will come into play now. Laws of exponents. So, I should have said it in the beginning. Please view my videos on exponents prior to viewing this. And also order of operations, just to have an idea. Okay? So, k raised to power 6, how are we going to make this now all squared? Okay? We see that this, we can, you ask yourself, how do you break 3 so that you can have 2 outside? You see, you can have 3 inside and then squared 2 outside. That's how you do it. Because 6 is 3 times 2. You always want to have the 2 outside. So this is like saying k cubed all squared. And this is your law of exponents here. This is your law of exponents. Okay? Minus 7 squared m squared. Already, we know that our x is k cubed. Now for our y, it is still double entities. So let's make it single entity. So this is k cubed all squared minus 7m all squared. So in this case, your x is k cubed, and then your y is 7m. So what will be your answer? Your answer will now be k cubed plus 7m times k cubed minus 7m. And if you expand this, if you multiply this, you get back this. Okay? Question 9. Question 9. 1 minus 169 m squared. Here this will be 1 squared minus, because we want to make it to look like x squared. In this case, x is 1. Minus 13 squared m squared. Square root of 169 is 13. So this is 1 squared minus 13m all squared. In this case, your x is 1, and then your y is 13m. Okay, your x is 1 and your y is 13m. So this will be 1 plus 13m times 1 minus 13m. Okay, 1 plus 13m times 1 minus 13m. Question 10. 100 minus 169m squared. I mean, without solving this, just tell me what it would be without solving it. Just from here, you see, from this, what would this one be even without solving it? It's going to be 10 plus 13m times 10 minus 13m. I mean, you can see the comparison. So this is 10 squared minus 13 squared m squared. Okay? So this is 10 squared minus 13m all squared. So in this case, your x is 10 and your y is 13m. So this will be 10 plus 13m times 10 minus 13m. Okay? Question 11. We're almost there. 2p plus 5 all squared minus k squared. Okay, don't be scared because you now see a binomial. You know, don't be scared. Okay, this means that x is what? X is what? 2p plus 5 and y is what? K. Simple, that is what it means. X is 2p plus 5, y is k. So this will be 2p plus 5 plus k times 2p plus 5 minus k. That is as simple as that. Yeah. You can write it this way. If you like, you write 2p plus k plus 5 times 2p minus k plus 5. That is if you want to get the constants together. I mean, if you want to get the variables together and then the constants. I mean, but this is good like this, you know. But you can, another answer you could do is 2p plus k plus 5, then 2p minus k plus 5. Still correct. 12 k squared minus 2p plus 5 all squared. In this case, what is your x? Your x is your k, and your y is your what? 2p plus 5. Okay? So this will be what? K plus 2p plus 5 times k minus 2p plus 5. Now, you have to be careful here. You got to be careful here. You know, here, because this is a single entity, you can just do minus k. But here, this is a double entity. So if you are subtracting, you have to put your parentheses again. You really have to be careful. Single entity, that's fine. But when you have more than one entity, you know, and you have a sign there, you've got to be careful. You have to put parentheses for the sign. Now, you might ask me, why didn't I put parentheses here? You can still put parentheses, that's fine. Okay? But you know that positive times positive is going to give you positive anyway. Okay? But you can still put parentheses. So now, let's open up the parentheses. This will be k plus 2p plus 5 times k minus 2p minus 5. So that when you expand that, it gives you back this. Okay? Trinomial times trinomial. Next one, question 13. Question 13. Two p minus 5 all squared minus 9k squared. Okay, so let's get this done. This is okay. It still is a perfect square. 2p minus 5 all squared minus 3 squared k squared. Okay, so that will give us what? 2p minus 5 all squared minus 3k all squared. So in this case, what is our x? Our x is what? 2p minus 5. And then our y is what? 3k. Okay? So this will now be 2p minus 5 plus 3k times, this is a single entity as well. So 3k, you know, it's now single entity. So you can add it like that, okay? Then 2p minus 5 minus 3k. You can have it this way. Yeah. Okay? Now, what if you have the next question here, 14. You have 9k squared minus 2p minus 5 all squared. Here you're working with a double entity here. On the subtraction sign, you have to be careful. Just like you did for question 12. Okay? This will be 3 squared k squared minus 2p minus 5 all squared. So this will be what? 3k all squared minus 2p minus 5 all squared. So here x will be what? 3k, and then y will be what? 2p minus 5. Okay? So this will now be 3k plus parenthesis 2p minus 5 times 3k minus parenthesis 2p minus 5. Okay? So this will now be, we now expand that, 3k plus 2p minus 5 times 3k minus 2p plus 5. Distributive property. -1 times -5 is +5. When that happens. Okay? Alright, 2 more to go. 2 more to go. Question 15. Question 15. 2p plus 5 all squared minus p plus 8 all squared. So in this case, we already know what our x is and our y is, right? Our x is what? 2p plus 5. Okay? And our y is what? P plus 8. Now remember, this is all difference of two squares. It is not sum of two squares. There's nothing like plus here. No, it is not. It is just difference of two squares. I know some of you might ask me, what of the sum of two squares? Well, we will do that. We'll talk about that in part 2. But the sum of two squares will not work. Okay? When you do that, you have two different outputs. And let's just focus on this for this video. Difference of two squares only. Alright? So here, our x, we have our y, so we just use the formula there. 2p plus 5. Let's put all this in parentheses. When you have a binomial, put it in parentheses, just to be on the safe side. Plus 2 plus p plus 8. Okay, I close this. Times, I open up 2p plus 5 minus p plus 8. And I close it. Okay, now let me expand it. Let me use distributive property and expand it. So this will now be 2p plus 5 plus p plus 8 times 2p plus 5 minus p minus 8. See that? And this will now be 2p plus p plus 5 plus 8 times 2p minus p plus 5 minus 8. Okay? So that will be what? 3p plus 13 times p minus 3. That is it. Okay? Then the last but not the least, we have question 16, 2p minus 5 all squared minus p minus 8 all squared. Okay, we know what our x is and our y is, right? Our x is what? 2p. Our x is 2p minus 5, and our y is p minus 8. Okay? So now we open up our parentheses, 2p minus 5 plus p minus 8, closed. We open up again, 2p minus 5 minus p minus 8. Okay? So now we apply distributive property and expand it. 2p minus 5 plus p minus 8 times 2p minus 5 minus p plus a. Okay, so this will be what? 2p plus p minus 5 minus 8 times 2p minus p minus 5 plus 8. And you now have 3p minus 13 times